All right. So now working with this definition here. So in an exam question, you could be asked to describe the properties of a liquid. So, and Tiana mentioned quite a few of those a while ago. So let's look at this list here, or this chart. All right, let's go on the other side. Everybody can see this?
Yes, sir.
All right, good. So here we have here about liquids having a definite volume. And this is the question we're going to ask. How do we find the amount of space that a liquid takes up? All right. What is a liquid shape? And those questions we're going to answer as well. All right. So, then this is our definition here. All right. And it also, liquids have definite, well, so liquids have a definite volume. All right. So definite volume means you can give it a number. All right, and can be measured. All right, let's just can be measured in the lab. And this is our focus here, can be measured in the lab using anybody know what we used to measure the volume of liquids in the lab?
Sir, I'm
No,
trying
sir.
to remember it, sir.
What was that? Nobody know? Okay. Well, okay, let's start there. We can use many things. So let us see. We have a couple of things here. I'm gonna put this on the screen so you can see it. Everybody seeing this?
Yes,
Yes,
sir.
sir.
All right. So what is the name of this device? What name is in there?
Graduated.
Graduated cylinder.
Right. That definitely is a graduated cylinder. So this is the device. This is the apparatus or the equipment that we use to measure the volume of liquids. All right. So I'm pretty sure you have seen something like this before. You have seen this before, right? At school.
Yes, sir.
All right. So that's what we use. All right. So let's move this to another slide. So cutting that one out and putting it here. All right. So this is our, and by the way, well, it's also called a measuring cylinder. In fact, let's put the word graduated, because anybody know what the word graduated mean? Why is it called?
Change,
Yeah,
sir.
go ahead. Yes,
It means change or something there.
mean change. Yes, it does mean change to a point, but what changes? What changes on the measuring cylinder?
The measurement, sir.
All right, so yeah, you could, yeah. All right, I like the answer, because that definitely is true. There is changes as if you should pour a liquid in it, and you continue to pour a liquid in it, you'll notice that the level of the liquid will rise, and that's what we mean by gradation. It's going to move from one number to another. Everybody understand that? Yeah.
Yes, sir.
All right. So gradations. Okay, gradations um are the markings. All right. Are numbers that that are seen on the measuring cylinder or on the cylinder. All right, so these are gradations, guys. Right. So if I ask you a question, what is the smallest gradation on the measuring cylinder here? All right, you're gonna look for the you're gonna look for the smallest number, but then there's a trick to it. What's the smallest number you're seeing on this diagram here? This one.
5, sir.
Very good. The smallest number is 5, but then don't you see some markings below 5?
Yes, sir.
All right, so those markings mean something. They have to graduate
Yes,
from there
sir.
before you can reach 5. So what do you think these small markings mean?
Sir, numbers, sir.
Numbers. Very good. What numbers? Any specific number we could call them?
Sir,
Let's zoom into it and see if we can get a closer look. All right. Yeah, so go ahead, Tiana.
sir, it's still numbering from 1 go up,
Okay.
sir. So the only thing is that say start from 5.
Oh, so it's still numbering from 1. All right. Let's see if that's the case. And that means that if we should number this will be 1, this will be 2, this will be 3, and this will be 4, and then we're seeing 5 there. All right, everybody seeing this?
Yes, sir.
All right,
Yes, sir.
very good. So that is the how we read a graduated cylinder. So throughout physics, this is one of the things that you're going to have to learn to do very, very accurately. All right, you have a lab coming up, which is a part of SBA that's coming up very soon. We're gonna do it online, so make sure you're there for that class. It could be on a third. Well, it could be Thursday. Which other day? It's Thursday. The next class you have for physics test. So confirm that
Thursday, sir.
Thursday. Good. So yeah, on Thursday, no, we're gonna Well, I'm not sure. We might not do the lab on Thursday, but certainly next week Monday it's very likely that we're gonna do that lab. But then what one of the things we need to learn about this cylinder. All right, so we know what the numbers are, but the other thing is we need to know the units. Now, the units here for measuring cylinder is in milliliters. All right, so we're going to have to learn about the milliliters. Now, let's go over here. Gradations are the markings that are seen on the measuring cylinder. Okay, they're seen on the cylinder. All right, so let's move this and put measuring to describe the cylinder. All right, that's should be in white. All right, so that's should be seen on the measuring cylinder. Let's fix these ease. All right. So now, so now the gradations here. So example, as you would be seeing there, one, and then you notice that you're going to have big and small lines. All right, so that's our gradation. All right, and as believe it was, well, who said it was moving? Yeah, gradate means to move up. Yeah, certainly that's what happens to the liquids here. All right, so these are your gradations. All right, so we call these graduations. All right, now a measuring cylinder. A measuring cylinder. All right, usually uh measures the volume of liquids in milliliters. So let's write out the word milliliters. All right. Now that's also written as ml. Some people write it as common M. So it's M big L or ml, or check this out, cm cube. All right. So you guys need to learn today that there are 3 units really we can use. Well, actually 2 units that we use for measuring the volume of liquids. And then one is in milliliters and there's a centimeters. Again, this is for lab purposes, guys. We said in previous class that the SI unit for volume is always the meters cube. However, in the lab, we went to get our measurements in milliliters and we have to convert them. So let me give you this information here, guys, that one note that one, or we could just say milliliters is the same as centimeters cube. All right, so the same thing, centimeters cubed, and of course milliliters. Any questions here, guys?
No, sir.
All right. So please remember that as a milliliter is the same thing as a centimeter cube. All right. And gradations are the markings on the sides of the measuring cylinder. All right. Used to measure the volume of liquids. All right. In the lab. All right. Now, these 2 information are important. All right. And what usually in terms of activities here, they will ask you to read the volume of liquids. A lot of questions have been asked, and even on CXE papers to read the volume of liquids. All right, now let me see something here. All right, here's one example. All right, and let's just bring in this paper here. All right, and hope everybody can see this. All right, let's just move this down a bit, and I'm gonna crop this. I think so. Then some space here. All right, guys. So now, for your activity now, you're gonna tell me the measurements that you're seeing here for each of them. So there are about there are actually 12 of them. All right, and if we start numbering, aim of this is to tell me what is the volume of each of them. All right, so but you think you can do that, class? Tiana, Nayoka, Carla.
Yes, sir.
Okay, good. All right, so this is your first activity after Easter.
Sir, this kind of look confusing to me. I'm not really right.
Sir, you can do number 1 for us.
Yeah, sure. All right, so let's just zoom in and see what's happening here. All right, now the key is to get as close to it as possible. So if this was a real cylinder, now you get close to it and then you would I remember now you're going to read at eye level. All right, now we're going to come into using the graduated cylinder. There are some rules. We'll look at that afterwards. However, let's look at this one. The question asks you, what is the reading in milli? All right, so in milliliters for each graduated cylinder. So, and this one here has a green liquid, and then this here rules. Let me just give you the rules here. Rules 1. All right. The first rule is that 1, you're going to read at eye level. All right. 2, read below the what we call the meniscus. Now we're going to talk about this word. Well, let's see if we have time to talk about it. Meniscus. Has anybody heard this word before? Meniscus.
No,
No,
sir.
sir.
All right. So the word meniscus, it means the curved surface of a liquid. All right. So in a measuring cylinder, especially if it's a slim one, the liquid tends to curve. It has like a curve like this. It's an up shaped curve. All right. So what they're saying is that you're going to read below that curve, and that curve is called the meniscus. All right. So I'm trying to write this word properly. It's rather elusive here. All right. So let's go. The meniscus. meniscus. Meniscus is the curved surface of a liquid. So I'm probably going to write that over here. Let's put that in white here. Meniscus is the curved surface of a liquid. All right, curved surface of a liquid, guys. All right, so, everybody understand that?
Yes, sir.
Yes, sir.
All right, good. So the surface of anything is at the top. So we're gonna find the reading for this. For the first one, it's at the top here. And if we read the gradations properly, we're seeing that it's just above 3. So this line is 3. All right, and then now the liquid is here. We could just draw the line there. So we're gonna read below that. We're gonna read below the line. So we're not going to read above, even though it might touch the top part, or the part of the curve might touch at a number above it. What we're going to read is below the line, below that curved surface. And so if here is 3, the next line above it is something. Now let's take a closer look now. These measurements, this cylinder is different from the first one that we looked at a while ago. If you go back to the first one, these measurements went up by 1 each. But you see that these small measurements went up by 1. All right. So if we were to continue, this would be 6. Let's go with the black marker here. This is 6. This will be 7. This will be 8. This will be 9, and there's 10. Everybody seeing that one?
Yes, sir.
All right. So that's another thing now. So that is one type of measuring cylinder. Remember now, every measuring cylinder is different. And so that's how you have to get accustomed to them or get used to it. All right, so now this one now, it's so each one of these, as you can see, it's not gonna be 1, it's gonna be something. Well, let's see what happens. This line here is 2, then there's another line after 2. Let's count the number of lines between 2 and 3 and see how many there are. All right, so this would be 1, and this would be 2. All right, now let's put in a point there to really make a point here. No pun intended, but 1, 2, 3. And so we have how many dots we see there so far?
4.
4. All right, so this is the 5th dot, and notice that the 5th dot has a longer line than the others. All right, so this will be 6, this will be 7, this will be 8, this will be 9. No, I put a point there for a reason. Anybody can guess what's the reason to put the point there? Or what is the name? What do you think is the name of that point that I put there? All right. Remember that we have 10, or this actually 9 lines between 2 and 3. But the reason I put the points there is that just like how we count the number of lines, we're going to put the same numbers there. So watch this now. This point would be 1. This point would be 2. This point would be 3. This point would be 4. This point would be 5. Everybody seeing that? So So how would we read this? Is we see 2, but the other lines, these little lines now, they're actually 2.1, 2.2, 2.3, 2.4, 2.5. Then we have 2.6, 2.7, 2.8, 2.9, and then we have 3. This is 3. Hope everybody is understanding what's happening here. All right. So so this is basically 3, and here is basically 2, but in between them are some points. All right, that's why when we're reading we have 2.1, 2.2, and those numbers. Now let's look at where this liquid is. This liquid is above 3, and there's another line that it touches above 3. But you see that?
Yes, sir.
So what would we call that line? It's the what number would we give that? Just like we did here.
Sir, 3.1.
Exactly. That's it. That's the answer. 3.1. And it's touching there. It's reading right here. So right there is gonna be 3.1. So that's the answer. I would put 3.1 here. But they get that?
Yes, sir.
Yes, sir.
Yeah, that's it. That's all they're gonna do for the rest of them. Same thing here. For the second one, we have 1, 2. Okay, so let's see how this one works. 2 is here. 3. This seems to be on the third line. Let's count that one. It's 0.1, 0.2, 0.3, 0.4, 0.5, right? 0.6, 0.7, 0.8, 0.9. Where does that surface of the liquid is? The surface of the liquid is above that. So we're gonna give it, remember it says read below the line. So we're gonna have to give it what number now? It's below 3. So it will be what?
2.9.
Yeah, that's it. 2.9. All right, 2.9. That's it. So so apply your knowledge now to this one. What would be the third one?
Sir, 4.1.
Yeah, 4.1. That's it. Beautiful. See it? No hard, not true.
No, sir.
Yeah. All right, guys. So that's where we're going to end it out today. Guys, do this for homework. Finish this for Thursday. All right, I'm going to send this in the group. I'm going to send it in the Google Classroom. So look out for it. All right, guys.
Yes, sir.
Sir, you're going to send it individual, sir.
Individual.
And send the file to Google Classroom, sir. Or you should do it on a paper in a book and send it in WhatsApp.
Oh, yeah. Yeah, man. All right, you can do it either way. So I'm going to send it in the Google Classroom, and then you can send me the answers on WhatsApp. Then just put the number, put the question and the number that you're doing, and the answer beside it, and you send that.
Okay, sir.
Yeah. So that's okay. You can send that to me. All right. So let's see, guys. Let me just save this. I think I'm going to just copy this. All right. Only 3 persons here today, but that's okay. Class goes on just the same. All right, I'll send this in the group shortly. There's a new one. Presentation and keep source formatting. And that's our class for today. Let's all right. So I'm gonna save this now. Today is April 12th, so I'm gonna put it in physics folder. All right, so this will be getting physics fundamental of liquids. This would be March. Put the date before. April. Sorry, this is April. April 20. April 12 and 2021. All right. Save that. You have a class after this, Tiana?
Yes, sir. So I have math class. So I think math is the last subject for today.
Math? You say math is what? You had class before?
Yes, sir. So we had English before your class, sir.
Oh, okay. All right. Did a lot of persons come to class or go to the class?
So I'm not sure, sir. So I wasn't checking how many
Oh.
persons.
All right, cool. All right. When you send this in the classroom, you tell me if you get it. All right. I can probably send you a copy as well to your WhatsApp. Let me. All right. So. All right. So. Tiana. Tiana. Okay. There it is. All right. All right. Let me know if you get it.
Sir, I just get it.
Okay, good. So I'm going to send it in the group so you can. All right. Yeah. All right. So. All right. So Tiana, I'll see you when we have a class again. Wednesday, may I go see you for chemistry?
Yes, sir.
All right. Jerry said here.
Thank you, and same to you, sir.
All right. Um, here are the notes for.